Hello Year 7, welcome to our next lesson on the Euclidean algorithm. But first let's do the answers to our problem solving from last lesson. So the first question was I asked you, can you work out what 16 to the power of 1/2 is? And what I did is I look here and I go, well, 16 to the power of a half times 16 to the power of a half. Well, that's 16 to the power of a half plus a half, because I want to have up here a power of 1, because if you did your homework last time, of course, you know that I just add those two powers together. So then I go, well, I've got this 16 to the half and I'm timesing it by itself. What do I times by itself to get to 16? And I go, oh, well, I times 4 by 4 to get to 16. 4 by 4. So 16 to the power of a half must equal to 4. Our next one is I said, okay, same thing. I've got 1000 to the power of a third. Well, I'm going to times it by itself 3 times. I'm going to go 1000 to the power of a third, 1000 to the power of a third, 1000 to the power of a third equals to 1000 to the power of 1, because 1/3 plus 1/3 plus 1/3 equals to 1. And then I think to myself, well, what do I have to times by itself 10 times to get to 1000? And I think for a little while and I go, it sounds like 10, because 10 times 10 times 10 equals to 1000. So 1000 to the power of a third must just equal to 10. Alright, my next one. I've got 64 to the power of 2/3. Now, this is a little bit trickier. So what I'm going to do first is I'm going to break up my 2/3 into two fractions. So it's 64 to the power of 1/3 times 2. Because you remember our index laws from last time, I times these two together, and 2 times 1/3 is 2/3, because I've got two lots of 1/3. So now I'm just going to work out my 64 to the 1/3 separately. 64 to the 1/3 times 64 to the 1/3 times 64 to the 1/3 equals to 64 to the 1, because I'm going a third plus a third plus a third again. And I go, what do I times by itself 3 times to get to 1? And I know, to get to 64. And I know it's 4, because 4 times 4 times 4 equals to 64. So now I know 64 to the power of a third equals to 4. But this is going to be a 4, which is just my 64 to a third is 4. And I've still got a squared there. So it's 4 squared, and 64 to the power of 2/3 is 16. I hope you got all of those right. So there's our 3 answers. Okay, on with the lesson. So I first of all want to talk about the division transformation, and we're just going to do a 655 divided by 8. I know that you've done this as part of your regular or basic work we've done. So I go, okay, 8s into 655 is 81 remainder 7. Pretty easy. But now I want you to look at writing it this way. That means 655 is 81 times 8, and that's only going to take me up to whatever it is, 648. And then I need to plus that extra 7 on to get all the way up to 655. So 655 is here, 81 is here, and it's 81 times this 8 plus the 7. So we say this is the dividend equals to the quotient times the divisor, which is the number we divide by. The quotient is the number we get when we divide, plus the remainder, plus the leftover. So get used to this division transformation, because you're going to be seeing it quite a lot. Okay, so the next thing to look at is the highest common factor. The highest common factor is just the highest number that's a factor of two numbers. So I've got a nice basic example here. What is the HCF? HCF stands for highest common factor of 72 and 48. So I write out all the factors of 48. Here they all are in this line here. I write out all the factors of 72. Here they are along this line here, and I look for the highest one, and I can see the highest number that appears in both of these is 24. So the next thing we're going to do is we're going to be using the Euclidean algorithm to find the highest common factor. Let me show you what that is. So what I want is the highest common factor. Sometimes it's written as GCD, and GCD means, I think it's just going to be greatest common divisor. Okay, so greatest common divisor, but that just means the exact same thing as the highest common factor. So when you see GCD, remember that's just the same as HCF. So what I do is I go, okay, I'm going to divide my 72 by 48 using my division transformation that you saw before. And there you go, 72 equals to 1 by 48 plus 24. That's my remainder. Now what I'm going to do is I'm going to get this term here. I'm going to get the 48, which of course you can see is the divisor, and the 24, which is the quotient, and I'm going to try and find the highest common factor, or the GCD, between them. So I get 48 and 24, and I go, oh, well, 48 is 2 times 24 with no remainder. There's nothing left over, so that means 24 is also the highest common factor of 72 and 48. It's a little bit hard to see with this example because we've got such a big highest common factor, but let's look with a new example now. So now we're going to find the GCD, highest common factor, greatest common divisor, of 2,322 and 654. So the first thing we do is we divide 654 into 2322, and you can do this yourself, but it's 3 remainder 360. So I've got my division transformation. 2322 equals to 3 by 654 plus 360. So now what I want to do is I want to find the greatest common divisor of 654 and 360, the divisor and the remainder. So I do it again. GCD of 654 and 360. I divide 360 into 654, and I get 1 with a remainder of 294. So now I go, okay, I want the greatest common divisor of 360 and 294. So I repeat my process. I divide 294 into 360, so in it goes 294 into 360, and it's 1 with 66 remainder. So now, same thing, okay, well, I want the greatest common factor, highest common factor, of 294 and 66. So, off we go again. Divide the greatest common factor of 294 and 666. We divide 66 into 294, and we get 4, remainder 30. Here's my divisor, here's my remainder. And I go, okay, well, I want the greatest common factor between 66 and 30, the highest common factor, greatest common divisor. So, you probably know the drill now. I divide 30 into 66. So 66 divided by 30 is 2, remainder 6. And let's take a look. You can probably already see the highest common factor, but let's go all the way. So, okay, I want the highest common factor of 30 and 6. So I divide 30. I divide 6 into 30. Let me get my laser pointer. I divide 6 into 30, and I get 5 with no remainder. So 30 is 5 by 6 plus 0. So the greatest common factor, or the highest common factor of 30 and 6, was just 6. So let me write that down. It actually was just 6 here like this, with no remainder. And 6 is also going to be the highest common factor of 232 and 654, or 2322 and 654, so it's 6. When you do a lot more algebra and modular arithmetic, we can prove why this works in a lot more detail, but I just want to show you a little bit why it works now, just to give you a bit of an idea. So, look at this one. I'll take an example that we know that's got a very nice easy number. And we're going to imagine we're going to find the GCD, greatest common divisor of 35 and 15. Now, you can do this in your head. You know it's 5, right? So we know that 35 equals 2 by 15 plus 10. But if I'm looking for the greatest common factor of 35 and 15, 35 and 15 both have to have the greatest common factor in them, which is a 5. And 35 is 7 times 5, and 15 is 3 by 5. So if I look at this first term here, I'm timesing something by 5, so I know it's a multiple of 5. I look at another term here. Well, this is a multiple of 5. They both have to be multiples of 5 because I've got a 5 in them. But if I want to add this something on here, I've got to add this remainder on. Now, if I want to get a multiple of 5, I need to add another multiple of 5 onto 5, right? I can't go 5 plus 6 and get a multiple of 5 because that's 11. I need to add 2 multiples of 5 together to get another multiple of 5, which means that the greatest common factor, this has to be a multiple of the greatest common factor, which is 5. So this needs to be a multiple of 5 as well. So the greatest common factor must be 5 because it has to be a factor of this and this. Otherwise, I wouldn't be able to add them together and get something written as 7 by 5. Okay, so let's now move on to our algebra. A little bit of review. I'll ask you to pause the video and try to do these. And let's have a go. So I hope you've paused the video and had a go. So the big thing here is 2x squared and x squared. We call these like terms, okay? So I've got 3 lots of x squared for my list, minus x because there's a minus x here, and it's a minus x, and plus y because there's a plus y there. So the big thing to notice here though, guys, is that we can't combine the 3x squared and the x, okay? Unless they've got the exact same powers, we can't keep track of them together because x squared and x are different numbers, okay? We can't count them together because x squared is probably bigger than x, might be smaller if x is a number less than 1. Okay, our next question is we want to multiply all these. Now this is a slightly different one. Notice we're just multiplying all these together. Everything's getting times together, so we're going to have a 3 times 2 times x squared times x times y squared. So notice it's the same thing. I've just written them in a different order. And that's 6x cubed, because I add the indices, y cubed, okay? So basically when I get these, I times the numbers and add the indices for the pronumerals. And you can see the reason why over here too. What I do is I'm just writing them in a different order. Okay, the next one, we're going to expand these brackets. So what we've got is 2 times by x plus 2. So what I'm going to do is if I've got 2 times x plus 2, I'm first going to go, okay, well, 2 times x and then 2 times 2, and that's going to equal 2 times x is just 2x, nice and easy, and 2 times 2 is just 4, nice and easy. Here's how you can think of this if you like. Imagine I have a rectangle like this and like this, and my 2x plus 2 is one side that's grouped together. So I'm going to say this part is 2, this length here is x, and this length here is 2. So I'm going to work out the area of this rectangle, and I can see this part is 2x because of course it's 2 times x, but this little part here, 2 times 2, so is going to have an area of 4. So 2 times x plus 2 is just 2x plus 4, like you can see in that little rectangle there. Okay guys, time for the homework. So our homework is going to be, I want you to go to the glossary, which you can see here. You scroll down to textbooks year 7, okay? Textbooks year 7. Then you go into Cambridge 8, open up your Cambridge 8. Scroll all the way down and you're going to see AP1 computation with integers. So you go down to computation with integers. I'll just wait for it to load, but it's in here. Hopefully you should find it and it shouldn't be too difficult. So you scroll all the way down up until you find this page here right at the end, and it's here. So you can see it's on page, bit further down. Oops, I just need to get my other thing here. It's on page 39. So let's just go back again and see if I can scroll. There it is. So page 39. I won't get the laser pointer out because it won't let me scroll. So you go on to page 39 and you're going to go through here and you're going to do questions 1, 2 and 3, and question 4 can be your problem solving question, so you can have a go at that on Google Sheets. Okay guys, thank you very much, and I'll see you all in the next video.